almost all have come. So let us start today's class. It is continuation of yesterday's class actually. Rating and overloading of power transformers, part 2. So I was saying that it is usually due to electrodynamic force, the sinusoidal force that existing between the coils or between the turns, and that occurs during a short circuit, sudden short circuit. That force is a bit higher than normal, but insulation might have already thermally aged or lost its mechanical strength and cannot sustain this force, and this force will disintegrate that one, and then it may result in breakdown due to electrical voltage ladder. So first reason is mechanical, losing the mechanical strength is the first reason, and then followed by electrical breakdown will occur. That's what is the usual mode of failure of any transformer. Now, results of aging investigations. Yesterday we have seen rate of aging based on tensile strength. So, if we go by tensile strength test, so it is reported to double every 5 to 10 degrees centigrade rise in the temperature. For every 5 to 10 degrees centigrade rise in the temperature, the rate of aging will is expected to double. But as per Monsinger, a scientist, he suggested 8-degree rule. So for every 8 degrees, the rate of aging will double. That is his rule. And based on the degree of polymerization, is a measure of the strength of this paper insulation, which is known as abbreviated as DP. It gives the in some way the strength of the polymer chains in the paper. So how strong or how long it is, the chain is. So like that, it will give indication of the strength of the material actually indirectly. So degree of polymerization, based on degree of polymerization, so if it is estimated, the aging is estimated for every 5.5 degree rise in temperature, the rate of degradation is expected to double. So these are all results of all investigations until now. But in 1961, Sigre working group, it opined that 6-degree rule for doubling of the rate of aging. So normally 6-degree rule is being adopted actually. So for every 6 degrees centigrade rise in the temperature, the rate of aging is expected to double. So this is what are the results of aging investigations. Let us see next. Operation of transformer winding at a temperature less than 80 degrees centigrade. So 80 degrees centigrade actually corresponds to 60% of the full load. So less than 80 degrees centigrade, which is corresponding to 60% of full load, causes negligible aging of the insulation material. So this is what is the observation results of investigations. So less than 80 degrees centigrade, not so significant aging is observed. And needless to mention that under very low temperatures such as 0 degree centigrade, aging is completely negligible. So if that is so, then occasionally, sometimes we can overload the transformer. So if it is therefore possible, so whenever necessary, under some well-defined conditions, to apply loads that can exceed rated power, at which some accelerated aging of the insulation material is caused. So not continuously, but under some conditions whenever necessary, so the transformer can be overloaded, because under normal conditions If the temperature is less than 80, if it is less than full load, then the aging is almost negligible. So certain conditions we can always overload the transformer. That's what it means. Then what are the types of overloads that will occur? So the overloading is classified as follows actually. There are two types of overloads or overloading: recurrent overloads and then exceptional overloads or emergency conditions. Recurrent overloads are defined as corresponding to planned or programmed power demands repeating over reasonable period of time. For example, even 24 hours period of time. So every day it repeats for certain amount of time. So it is pre-planned or even programmed power demand. So every day for 1 or 2 hours, it exceeds the rated current, rated load of the transformer, ratings of the transformer. So such type of loads are called recurrent overloads or normal load cycles due to normal load cycles. And the next kind of overloads are exceptional overloads. These are actually unforeseen, not predetermined, unforeseen conditions. Unforeseen conditions, why unforeseen conditions will come? There may be an accidental load, sudden load peak, which is not actually predicted every day or not even seasonally, but sometimes there may be some accidental load. Okay, so such kind of accidental load, or sometimes a transformer in a particular route, transmission line route, might have damaged. So what immediately is to be done is that line has to be disconnected and the load corresponding to that line, transmission line, will be shifted to another transmission line where another transformer will exist. So that transformer to which the load is transferred will be overloaded definitely. But this is emergency condition, not expected, not a planned condition. So this is known as exceptional overload again. So exceptional overloads are rare compared with the recurrent overloads, because recurrent overloads planned and every day they may occur. But exceptional means, as the name itself defines, it is exceptional condition or emergency condition. Therefore, greater and longer overloads may be tolerated under exceptional conditions. So, as the cumulative loss of life is small, because that will not continue forever. For continuously every day you are overloading for 2 hours, so will have more impact than occasionally once in a year or once in few years suddenly some emergency might have occurred. So that condition in the causes negligible aging compared to its long life of 20-30 years. So that's why exceptional overload can be longer. They can be longer without any problem, can be tolerated. It doesn't mean that exceptional overloads will be longer. They can be for a longer time without any problem. That's what it means. Next, on the oil temperature measurement. Now, how the condition of the transformer or thermal condition of the transformer can be assessed. So, it may seem that a measurement of oil temperature of the transformer it is simple, right? We can keep some sensor in the oil, temperature sensor. So, it is very simple and convenient. So, oil temperature can be measured and thermal state of the transformer can be assessed. Okay, this is the temperature. So, we should not overload, something like that. But however, this would be dangerous because and also unsuitable, because there is a difference in time constants of winding and oil, which will be faster in rising the temperature rise, winding or oil.
So winding.
So winding temperature will rise very faster and oil temperature will rise very slow, because it may be several hours in case of oil, but winding temperature may be in minutes. So a measurement of oil temperature will not give you exact idea on what is happening in the windings. So what gives the temperature of the windings rise much faster than that of the oil. Moreover, heating of the windings relative to oil is also not constant. Say for example, at low temperatures and high temperature, the relative heating of the windings is different actually due to viscosity of oil. Means this is temperature dependent property actually. So therefore, due to these problems, sensing oil temperature and telling about the condition of the transformer is not a good idea. But what is a good idea? Then a thermal image of a resistor immersed in hot oil. So what can be done is a resistor can be immersed in a hot oil and causing a current proportional to that in windings is most suitable, but it gives only instantaneous values. For example, you have a resistor, and what you do is always uh, allow to flow, proportional current through the resistor. Whatever winding current is there, you allow to flow proportional current through the resistor and immerse that resistor in oil and find out the temperature using thermal image or whatever it means. So the temperature of the resistor, because the current flowing through the resistor is proportional to the winding current, so it gives an indication of the winding temperature. You can always calibrate the winding temperature. So, but it gives instantaneous value of the temperature only transformer. So, instead of measuring oil temperature, a resistor may be immersed in the hot oil, causing a current proportional to that of the windings. So, through that resistor, if you somehow arrange that a proportional current that flows through the winding is allowed to flow through the resistor, then what will happen? The temperature is also proportional to what it occurs in the windings. So this way we can measure instantaneous value of the temperature of the winding. By calibrating the measurement system, we can exactly find out what is the winding temperature using this method.
Sir,
Uh,
I had doubt. Can I ask, sir?
yeah, yeah.
Sir, when you why can't we use a thermistor instead of thermal image, sir? I mean, if you directly use a thermistor, it is a sensor, so it will directly sense the temperature of oil and winding also, sir, directly.
Inside the transformer, very high electric fields, high voltages will be there. Any small sensors which will cause, which are based on some voltage development, etc., will fail to work actually.
Okay, sir. But sir, I was trying to say thermistor which works on current, sir. That's why.
Even if current is there, transformer means what? Inside what will be there? Both electrical and magnetic field will be there.
Yes,
So
sir. Yes, sir.
So, and that electrical and magnetic fields are not so small actually. They are very huge. So that's
So
why
what I'm trying to
optical
ask is
method,
that, sir. Yeah,
okay,
sir. What I'm trying to ask. Okay, sir. Say, sir. Say, sir.
optical methods are effective in the sense they will not get interference by any of these things. Yeah, yeah, you say. Of course,
Yeah, sir. What?
people are trying several methods for monitoring of the condition of the transformer.
No, sir. What I'm trying to ask that if you are supposed to measure the temperature winding, then why are we using thermal image of resistor in oil? Directly measure the temperature winding, and for oil directly measure it oil through some instrument. Why are we transferring it to oil for measuring the temperature of the winding, sir? That's what I'm not getting, sir.
Winding is filled with completely oil inside the oil. Okay. The
Okay, sir.
optical method if you use and then if you focus on the winding directly, so you will not be able to get the temperature of
Sir, you are not audible, sir.
yeah. So this is Actually, both the PCs I lost the connection. Maybe some problem in the campus. So I have logged in through my mobile internet. Maybe a little bit slow. If there is a problem, let us know. Let me know so that we will postpone the class. Not an issue. So, are you able to hear me?
Yes, sir.
Yes, sir.
Yes, sir.
So, a thermal image of resistor immersed in the hot oil. So, which is flowing the same current proportional to that in the windings is most suitable, but it gives only instantaneous values. So, this was what was told just now. But the practical method, the most practical method is and suitable method is of determining the transformer overload capacity in magnitude and time as a function of the previous load conditions and the ambient temperature. So it depends, the temperature, current temperature depends on the previous load conditions as well as what is the ambient temperature. So based on design of a transformer, it is possible to estimate the temperature rise for a for a given history of the load as well as ambient temperature. So this can be calculated in advance, and the overload conditions for the large number of cases. For example, different types of loads or different levels of load can be calculated based on the standard transformer design, and then they may be presented in the form of tables or graphs. So this is most practical method that is being adopted in the transformer industry. So what are the IEC guidelines for loading? So next comes the IEC guidelines. The IEC study committee number 14 published a guide in 1972 applicable to transformers complying with the IEC publication 76. So several preliminary maximum limits are fixed in accordance with the characteristics of the material and equipment as follows. So what maximum limits are fixed is, as per the load, 150% of the rated current for the current under normal cyclic conditions. So under normal cyclic conditions means under recurrent load conditions, you can go up to 150% of the rated current. So this is the maximum limit that is proposed. And then 140 degrees centigrade of hot spot temperature under all conditions. So in no condition transformer temperature should be allowed to exceed 140 degrees centigrade. No condition means either in exceptional load condition or in a recurrent load condition. The transformer temperature should never go beyond 140 degrees centigrade, because it will cause drastic aging of the insulation and it may damage very soon. The life may decrease very fast. So that's because every 6 degrees centigrade the aging doubles. You can understand, what is. If it is 20 years, so if 6-degree rise is there continuously throughout the life, then its life becomes 10 years. If another 6 degrees are there, then it is 5 years. So you can imagine how much decrease in the life of the transformer will be for every 5-6 degrees rise in the temperature. Therefore, they have decided that the guidelines, IEC guidelines decided that it should never be allowed to cross 140 degrees centigrade. And oil temperature also, there has been a specification that 115 degrees centigrade of oil temperature, even under exceptional conditions, it should not be allowed to exceed 115 degrees centigrade. These guidelines are based on the research being carried out by various labs, and then the study committee investigations on this. So therefore, these are based on well-established results actually. So the industry has to follow these to minimize the failures of the transformers. The characteristics of the equipment such as terminals and tap changers can again possibly justify even lower limits. So due to additional effects due to terminals or tap changers, so maybe a little bit lower limits can be adopted for them. So now calculation, as per the calculations, it is accepted that continuous operation of the hotspot at 98 degrees centigrade leads to a normal rate of degradation that leads to 20 to 30 years of age. Okay, so 98 degrees centigrade hotspot temperature. So hotspot temperature 98 degrees centigrade would lead to normal aging, means 20 to 30 years without any problem the transformer can survive. This is what is accepted in general. And then this rate is accepted to be double for each increase in temperature by 6 degrees centigrade. That is what Segre rule also. So this is what is accepted. But if you see Blue Metal, he gives the formula for integrating time temperature area. So if the temperature is constant, the aging can be calculated from this formula. A equals to T into e to the power of nd. A is equal to T into e to the power of nt. What is A? A is aging units. Aging units is a constant actually. T, small t is time and capital T is temperature in degree centigrade. N is a constant which is derived for 6 degree rule as 0.1154. Now, from this, how do you estimate for example, I give all the constants here. A is a constant, N is a constant, temperature value I give you. So, how do you estimate the life of a transformer? Life means how many years it will survive. Or how much time it will survive. It is simple actually. T into e to the power of nt equals to a, right? From this t is the time actually, is equal to a into e to the power of minus nt. That's it. This is the life. At a given temperature T and for a given value of n, 6 degree rule or whatever it is, and a given constant which is aging units for a given equipment that is fixed, then T can be estimated. T means life. The lifetime can be estimated using this formula just by rewriting. Of course, this constant A, etc., or even N, etc., can be calculated from given data. Suppose if I give this much causes the degradation of the transfer, this much temperature for this much time causes the aging units of this much, then based on that you can get the constants and then use the same for the estimation of the life. For example, assuming 6 degree rise will lead to rate of aging as double. So for that also you can estimate the value of n. So like that this formula can be used for estimating the life under any given temperature conditions. And further to IEC guidelines, they contain actually two groups of tables, translated in the form of graphs valid for both types, ON, AN, ON, AF, or OF, AF, OF, WF types of transformers, these two groups. So these tables are actually based on simplified load diagram as proportion of the rated power. For example, some factor times the rated power of the transformer and for a duration of 24 hours. So what I mean to say is, what is the guidelines consider a load curve like this actually. So the initial load equals to K1, which is some factor of the rated power, and it rises to K2 for certain period of T hours and then falls back to K1 again. So this is what is considered in IEC guidelines. I'll just give you the load curve to make you understand. This is T, this is load. So it is like this actually. This is K1 and then it rises to K2 for T hours and then falls back to a K1 again. So this is again 24 hours. 24 hours. And this duration is time T. So this type of load curve has been considered in IEC guidelines. They give clear indication of how much load can be given to the transformer under different conditions to minimize the degradation, minimize the loss or minimize the loss of life of the transformer. So this is about the guidelines that exist, and then rating of the transformer, overloading of the transformer. Yeah, so if you have any questions, you may ask me.
Sir, when will we have the next lecture, sir? Sir, tomorrow we have the next lecture, sir.
Tomorrow, maybe we have the other lecture we will have power cable technology.
Okay, sir. Morning or same time, sir?
What is convenient to you? Tomorrow.
Sir, evening
tomorrow
only.
Morning,
evening only, sir. Evening is more convenient.
Okay, but it seems that issue is occurring only in the evening. Morning, I have done several meetings. I never faced any problem. But evening, yesterday also, the other day also, it is happening. Now also I am running through my mobile internet, not institute internet. And one question I would like to ask: is it good that if I send the video and then after that have a discussion, or
Yes, sir.
is it good to have live lecture like this one?
Pre-recorded, sir. Pre-recorded.
Sir, pre-recorded will be good, and
Pre-recorded will be better, sir.
Shekhar sir also doing this, and we are convenient with this method.
Yes, sir. We are more convenient.
Okay, so all others also do agree. Then in that case, I will record them and then send it. It will be easy for me also. Only that you will be missing live.
Yes, sir. Sure, sir. Sure, sir. We agree, sir.
The live lecture could be just once a week, and then we could just discuss all our problems there.
Okay. So
Sir, and it would also be, sir, and it would also be better if you in the live lecture discuss the assignment problems which you had given. For example, that power cable assignment. So it would be better that you all discuss all the assignments with us, sir.
So actually, this power cable technology doesn't have any tutorial kind of thing. So you have to come out of that BTech level of teaching. Okay. Here more is expected from you. I can see it becomes a tutorial kind of thing. So that kind of spoon feeding we should not do. You have to discuss among yourselves after assignment. That sensitive period is over. Sensitive period means the the majority of the people, means those who are expected to submit might have submitted. After that, you should have a discussion among yourselves. Of course, there is one limitation for you, that you are not staying in hostel. So, but you can have among yourself some online meeting, or somebody should be discussing whatever he has done. So otherwise, whatever somebody has a doubt, So that kind of interaction is expected at this level. Okay, if you
Okay, sir.
require these things, I can instruct a TA to do that. But think about it. Normally at this level, we do not do like that.
So, but can we ask doubts to TA, sir, at least for that much?
Okay, so I will ask Purnam Sheikh to clear doubts regarding that assignment. Okay.
Yes, sir. Thank you, sir. Yes.
Okay. Purnam Sheikh is there?
Hello.
Pranav, Purnam Sheikh is there or?
No, sir. Actually, sir, few students contacted me also regarding power cable technology assignment. Sir.
You are the you are the TA for this course, right? Not Purnam Sheikh.
Actually, sir, I'm for power equipment, sir. Yes.
Okay. So, okay, for power cable technology, Purnam Sheikh will be explaining. For power equipment, Pranav will be explaining. Okay, assignments, but not immediately. After some time, we will give enough time for you to submit the assignment. Then after that, it will.
Okay, sir.
Okay, sir.
Okay, sir.
Okay, then tomorrow I will send a lecture of power cable technology. Then we will have a live session once in a week. Am I correct?
Yes, sir.
Yes, sir.
Okay.
Sir, can we have that session in
Yes, sir.
evening, sir, if possible? That live session.
Any time is okay. Evening is convenient for me also. But this kind of interruption,
sir.
I don't know how to address this one. I am trying to find a solution actually. Okay.
Okay, yes.
Okay, sir.
Okay, sir. Thank you.
Okay. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Yeah.
Thank you, sir.